Okay, so this is a test of the Lion battery. It's 4S3P Sanyo 18650 cells, total of just over 10,000 milliamp hours in a solo with larger than standard props and a custom homemade BMS emulator. I've got open solo and Solex running. It is January the 19th of 2020, about 2 o'clock in the afternoon. Beautiful winter sunny day. I'm just connecting with my Android tablet. Let's see if I got the video coming through. Yeah, I got the video coming through, and it says that the battery's at 89%. If I click the telemetry, I get about 4 volts per cell. I actually charge them up to 4.2. So yeah, it's reading slightly low than real, but it's within 0.1 of a volt, maybe 0.2 of a volt. So I'm just going to try and do a duration test really and see how long I can hover when I get down to about 2.5 volts per cell, which is what this is capable of managing. So I'm just going to start the GoPro recording. Sometimes the remote connection doesn't work with the GoPro, so I might have to start it manually. It's weird, it works sometimes, doesn't work other times, but it's recording now. I'm going to hit fly and let's see how I do. So we started the flight at about 2 minutes 15 on my recording here. And I'm now just hovering. Now it's interesting, on my battery meter under load, it's jumped right down to 55% where the motor's under load. So basically, I think my homemade battery pack has got some high resistance joints through the balance connector. I mean, it's something I may need to look at. I did a homemade spot welding job on the battery pack, and I reckon maybe I got some high resistance joints, or maybe actually that's just the nature of what happens with these particular lithium ions, given that I'm running them at close to their maximum rated 10 amp continuous capacity. Okay, so I'm just going to take it out a bit and up a bit, up to about 15 meters. Okay. Right. So interesting, I'm not getting a wattage reading from Solex rather. it says bat 54%, and then this number I don't understand of 327.7 degrees. Actually, that's, is it a compass heading? No, it isn't. So here we have just a crummy view of what I'm getting on the controller. You can see we are 3.6, 3.5 volts. So I haven't changed the return to home failsafe on this, so this will come and want to return to home and land at the normal default voltage reading, whereas these lithium ions can go down to 2.5 volts per cell. So I will just cancel that when it happens. So again, we're still up in the air. My cells are again reading through my homemade BMS emulator at OK values. Signal is good, and we're just hovering. So just to sync with the recording here, I'm at 7:12. So this has been going, what, 5 minutes flight time, because I took off at about 2 minutes 15 seconds on my main camera. The flight time meter on Solex doesn't seem to be working either, or am I, maybe I've done something wrong. Yeah, so the battery emulator is not working 100% perfectly, but at least I can see my cell voltage readings. Let's look at the beast in the sky. There it is. And then there we go. So I'm just going to see how long I can go. I'm going to keep recording throughout and just see how long I can do. And this has got the GoPro Hero 4 Black on it with the gimbal, and then slightly larger than stock props, which I think will help the extra weight. Because the custom battery pack is heavier, but I think about 68 grams heavier than the standard 3DR Solo pack. So it's carrying some extra weight, but it's got something like 50% more power capacity on board. So let's see how long a flight time I can get. It's about 3 or 4 degrees C out here, but it is sunny. Battery is at 48, 50%. There is some smoothing going on here, but on the battery readings in the Arduino BMS emulator. And thanks to Webbs and the other guys on the 3DR Pilots forum for their work on sorting out how to make a BMS for the Solo. I just took their code and their circuit and modified it, but I know that within a few weeks there's going to be at least one commercially available alternative BMSs. I think Mad Hacker's working on one. I think there's another, is it Profi CNC or something other? They're working on the other one. But yeah, it was the guys on 3DR Pilots forum who've, I think, figured it out first. So big kudos to those guys. So at 3.4, 3.5 volts per cell. I've been going for just 8.5 minutes so far. So I took off at about 2 minutes 15. Shall I see if I can move my gimbal a bit? Yeah, let's look down. That's up. So the gimbal is fully working, and I'm just in a hover. With a stock battery, I tested the hover with these slightly larger than usual props. With the extra weight, because I put a dummy weight on, it hovers at about 250 to 260 watts. So even when I get down to 2.5 volts per cell, that power draw would still keep me just under the 10 amps per cell maximum, given I've got 3 cells in parallel, 4 cells in series, so 4 S3P cells. So in a hover, at least, even at the lowest voltage at the end of the flight, I'm within the 10 amps per cell according to the data sheet. But of course, if you threw it around and threw it hard into the wind, then I dare say you could easily exceed 300 watts per cell, and then you'd kill the batteries pretty quickly. But anyway, there's very little wind today here, so wind is not a problem, and I'm just doing a hover test. So where are we time wise for now? Okay, we've just exceeded the 10 minutes because the clock on the video is at 12:26, so we've done 10 minutes and 15 seconds. My battery reading is 40%. On Solex I'm seeing a low of 3.2 volts per cell. Again, this is a pretty crummy potential divider feeding into the A to D port of a Arduino Mini, with using the built-in Arduino voltage reference. So I'm not going to get great precision. And the annoying thing is that you know, the way that you have to configure the way you read it is that you're measuring the stack of cells in turn, not each cell individually, and then you have to subtract the lower one from the higher one in order to work out what. So for example, you measure the voltage of cell 1 and 2, and then the voltage of cell 1, and then you subtract cell 1's voltage from cell voltage 1 and 2's voltage in order to calculate cell 2's voltage. That's what happens on the Arduino, but that means with that maths, you're doubling your measurement error. So if I were making a better circuit, I would definitely improve my voltage reference and possibly look at ways of getting better precision on the voltage reading. So right now 38% on the stated battery. That stated battery percentage is calculated on the Arduino in the battery bay, and basically it's just a linear curve based on the starting voltage of 4.8 volts per cell down to the minimum voltage, which I think I set at 2.5 or 2.7 points per cell, and it just interpolates. So there's no Coulomb counting going on here. It's an estimated battery capacity generated by the cell voltages. So just as they're not going to be perfect, this is not going to be perfect. I noticed up there I'm getting some toilet bowling as it's in the air. I mean, I wonder why that is. I mean, it's not getting out of hand. What I might do is just move the thing out and forward just to see if I can cancel that out a second. Okay, so I've just moved it a bit. Let me move the camera, find it in the shot once more. It's still in the air. There it is. Got some zoom. So right now we have done 13 minutes, 15 seconds on this 10,000 and something milliamp hour battery pack. It says my battery's at 30 to 35%. On my cell voltages are around 3.0 to 3.2 again. Okay. Okay, so the return to home just kicked in, so it just went up to its return to home altitude of 42 meters. I'm just going to bring it down again. If I can find the thing. Let me zoom out. There it is. I'm going to bring it down back to about 15 meters. It's beeping like crazy, but I'm still at 3 volts per cell. Okay, so 20 meters, just bring it down a bit more to 15 meters. Okay, it's at 15 meters, and we've done 15 minutes so far, and we are still showing at 3 volts per cell. Okay, that's 16 minutes so far, and my iPhone that I was using to record other stuff has just conked out, but I'm going to use this phone on a tripod as my main timer, and I'll just plug a battery bank back into my iPhone and so I'm still showing 3 volts per cell. And my video recording timer says coming up to coming up to 18 minutes flight time. Okay, that is 18-minute flight time. And again, I wish I could take a good photo of this, but I don't think my screen recording app works on Solex, so, or if it does, it often crashes the old Nexus tablet I'm using. Okay, I'm getting another warning on my controller saying flight battery at 20%. Cells are still at about the 2.9 volt mark, so I've still got half a volt to go. We've got to get lots of reminders to return home soon on the R2 controller. And we are at, well, coming up to 20 minutes flight time in 15 seconds. Okay, that is 20 minutes in the air. And my cells are now reading 2.8 volts, 2.9 volts. Again, I'm getting lots of buzzing from the controller saying return home soon. So it says, again, my calculated battery capacity at about 12%. My cells are reading it varies, 2.7, 2.8 volts. And we are at coming up to 22 minutes in about 5 seconds. Okay, that's 22 minutes. So I'm just going to look at the cell voltages, and as soon as I see them hit 2.5 volts, then I'm going to bring it down. Any one of them. Right, my iPhone is come back on again. So you just check, we're picking up this at 25 minutes recorded time, so in 10 seconds that will be 23 minutes flight time. So we started at 2 minutes 15 and we're now 25 minutes 15, so that's 23 minutes flight time. And on Solex, this is what I see. I see my batteries around 2.7, 2.8, 2.9 volts. It's saying 3%, 1%. I think because I set 0 at 2.7 volts. But actually I'm gonna, just this one time, I'm gonna take them down to 2.5. I want to get, it'd be lovely if I could get to 25 minutes flight time with the gimbal, with the GoPro, in a hover. There we go, we're still hovering. Beautiful winter's day here. Again, I'm getting all sorts of messages on the controller. Okay, we are coming up to 24 minutes flight time. Okay, that's 24 minutes, and I'm now seeing one cell just dip down to 2.5 for the moment, but then jumps to 2.6. Can I get to 25 minutes? So we are just a few seconds away from 25 minutes. Okay, 15 seconds away from 25 minutes. So on my cells, I'm seeing cell 0 is 2.7 volts. Actually, cell 1 is reading 2.2 volts, so that's a problem. Okay, that's just dropped down, so I need to land. Cell 2, in fact, let's just take a look at it. I'm just about to land, and one cell's dying. So time to bring it down. Let's bring it down, and let's land it. So. Oh, it landed and then took off again for some reason. So. Okay, it's down. Let's see, it's proof that it's down. There we are. And let's just go and have a look. Now it's down. What are we reading? We are reading cell 3 at 3 volts, cell 1 at 2.4 volts, cell 2 at 3.3 volts. So, I may have a problem with that cell 1. So for example, if one of the welds wasn't good and 2 of the cells were taking all the load, then that would have killed it. Maybe I got a hell resistance joint. I made it with the car battery spot welder. It's not the best way to weld these cells together if you want them to be reliable. I think I might have to invest on a proper battery 18650 spot welder, and then change out the first bank of batteries if I've knackered them. But I think the other bank 0, 2 and 3 are completely fine. In fact, they could have kept on going. So anyway, there we have it. Recording's still going. It flew for 25 minutes. Okay, so this is what it looks like under the hood. You see they've got the Solo custom Molex connector, which I bought a couple of. Then we've got at the bottom a APM power module, which I just used some thick copper wire to have the power lines go through the shunt resistor on the module, and to do it produces 5 volts through a little switcher on the bottom, and then there's a potential divider for the voltage, so you can read that through a micro the same way a Pixhawk would. And then here's a Arduino micro, is it? Pro micro. better than Arduino Nano in this case, because you need the extra A to D ports and the I2C pins to read the 4 voltage cells plus the overall voltage from the APM unit. So I'm using 5 A to D pins and the I2C pins, because the Arduino talks to the Solo through the I2C SM bus, and there's a little tiny 1/2 inch OLED display that when it's running tells me the voltage and status before I take off. It's quite useful, and it doesn't add much weight. I think this thing is, can't remember what it is, I think this is about 68 grams. Could make it lighter, doesn't really need the switcher. A linear power supply would be fine. So but actually a very simple circuit. Cool.